Hello everybody, this is Mr. Bowman. So today we're going to be looking at a couple special types of triangles. One type is isosceles triangles, where we have two sides of the triangles have to be congruent, and therefore two angles are congruent, and equilateral triangles, where all three sides and all three angles are congruent. So we're looking at this one, and since all the side lengths are 6, that makes this an equilateral triangle, which really breaks down to equal sides. Lateral means sides. So equilateral is equal sides. So if they all have the same sides, that means all the angles are the same as well for it to be equilateral. So since we know that all the angle measures, so the sum of the angle measures, I should say, in a triangle add up to 180, if they're all the same, I can just divide by 3 and figure out what each of them are. So 180 divided by 3 comes out to 60 degrees. Over here, this one is not necessarily equilateral, but it does say two things are congruent. So the side XW and the side XY here are congruent. Those hash marks tell me that. So this is an isosceles triangle. So if that's the case, then the two base angles, which are the, if you imagine that these are kind of the sides, then this would be the base of the triangle, the side that's not marked. So the base angles would be the two angles that touch the base. So over here with angle Y and down here with angle W. So if that's the case, then those two angles have to be equal. So if angle Y up here is 40, then angle W has to be 40 as well. So now you might be saying, Mr. Bowman, but we're looking for angle X. I know, but using the same logic we did over here about the angle measures equal 180, if I know this one's 40 and this one's 40, I can just subtract those from 180 to find this top angle. So 180 minus 40 is 100, and that's the measure of angle X. Okay. All right, let's look at another one just to run through here. So this one that's set up a little bit differently. So this one is isosceles, right? We have 12 and 12. So it's saying angle J down here is 80. So that makes angle L has to be 80 as well. So I have 80 and 80, which is 160. So my leftover up here at the top would be 20 to add up to 180. Over here, this one is 5. And so I don't know anything about the sides, but it does tell me all the angles are equal, which is enough to tell me it's equilateral. It's either all three sides or all three angles. So if that's the case, then all the sides have to match as well. So if HG is 5, HI has to also be 5. Okay, so that's kind of the general rule of how these work. Now we have a couple different types of questions in here. So like this one, we have an equation now, but notice this is isosceles. So these have to be equal. So to find our measures here, all you have to do is set these equal. So 2x plus 21 equals 5x minus 18. Solve for x, and then plug that x back in, and you can get your sides here. And to get q, notice you'll just do the same thing we did on the last one, where it's 180 minus r minus s, and you'll get q. Okay. And then the last type over here, this one is more of a proof, so I'll actually run you all the way through this one. So just like when we did our previous proofs, you can start by sending your givens to the proof, so you make sure those are in there. It's always a good way to start. So let's look at what we have here. We know BC is congruent to BD, so this side, kind of our right side, is congruent to our left side. And we know that BA bisects CD, okay? That is not a congruent statement right now, but it can give us one. So guys, remember, if something is bisected, it means it cuts something into equal pieces. So I can say that the right part of this one is equal to the left part, and that's what I'm going to do. So I'm going to say that CA is congruent to AD. And we know that because it's the definition of a segment bisector. It cuts it in half. All right, so now I have two congruent statements. So the last one I can get here is, remember, we have that shared side here if we're thinking about this triangle and this triangle. So I have BA is going to be congruent to itself. Hopefully by now you're getting in the habit of whenever something is congruent to itself, you know it's that reflexive property. Okay, so now I have three congruent statements. I have BC, CA, and BA, or AB, whatever. So that is a side, and a side. So I can say my triangles are congruent. So I have triangle ABC is congruent to triangle. And then see what over here. So ABC would go to ABD. And that is from our side, side, side.